everybody, my name is Miss Sarah, and on this episode of STEAM Club, we are going to be talking about something called refraction. Now, you've probably heard the song Twinkle Twinkle Little Star, but have you ever wondered what actually causes stars to twinkle? Well, that's what we're going to be talking about and experimenting with in today's episode. Now, I've grabbed my little flashlight here to show you something, which is that this is a source of light, just like a star. And if you're able to see it pretty well on camera, you might be noticing that it doesn't twinkle the way that a star does. It stays very consistent. It's not moving around except for any movement that is caused by my hand moving. This light source is very stable. And that's actually true of stars as well. It's not the stars themselves that are having those flickers or growing dimmer and brighter. It's actually the light waves experiencing refraction. When light travels, it travels in a wave. So let me give you a little drawing to help you visualize. So the light from our star travels in a wave just like this. And this wave is going to keep going and not change its shape unless it encounters something like water. So when our light wave encounters a drop of water, it is going to bend or refract. So instead of continuing out just like that, it's going to start traveling at a different angle. And this is called refraction. So let me show you a little experiment to demonstrate how refraction works. So right here, I have this clear bowl, and you might be able to see if I put something in it, like my finger or this pencil, the pencil looks pretty normal, right? Like it looks like a normal pencil. But if I fill this with water, you might notice something a little different. All right, now that my bowl is filled with water, let's see what happens when I put in this pencil. Show it up to you closer. You might notice that this pencil looks like it's bent where it hit the water. And that's not because there's anything wrong with my pencil. This is just a normal pencil. It's because those light rays that are interacting with the water are bending or refracting. And this is true for stars as well. So those are not changing, but when they come, the light waves from the stars come in contact with our atmosphere, they experience refraction. And that's because our atmosphere, or the bubble of gases that surrounds our Earth, is full of water vapor. So there's lots of little water droplets up in the air that when the light waves hit them, they bend and refract. And that is why when you're looking up at the sky, you might see those stars moving around. So let's do a little experiment to see how this works. So if you're going to do this experiment along with me at home, these are a list of the things that you're going to need. You're going to need a bowl with smooth sides, just like I have here. Make sure that you don't get something like this pitcher that has these bumpy sides, because you might be able to notice that when I put my hand in this one, my fingers look kind of distorted, and that's just because the bowl isn't smooth. You're going to need some water, of course. You will need either a piece of flat construction paper or some tin foil, or really just any material that is thick enough that you can't shine a light through it, but that you can poke holes in. You'll need a pen and you'll need a flashlight. I have this one here, but you could also use one on a cell phone if that's all you have. So our first step is that we're going to take this piece of paper and we're going to poke some holes into it. And you could put these in the shape of a constellation if you like. So I have poked holes into my piece of paper in the shape of the Little Dipper. So let's go on to the next step. The next thing that we're going to do is we're going to take our flashlight and we're going to shine it behind the piece of paper to see what it looks like. So here I'm doing my best to keep my hands still so that you can see that this constellation is not twinkling. When I manage to keep my hands nice and still, this should stay really consistent. And that would be true of a star as well. But let's see what happens when we put this behind some water and experience refraction. let's take this piece of paper and put it behind our bowl of water and see what changes that makes when I turn on the flashlight. Do you notice that this doesn't look as consistent when I have it behind the water and there's more movement with the way that the light is coming through? All right, now let's see what happens if something is stirring up this water. Say if it's a really windy night and the water in the atmosphere is moving around. So I'm just gonna get this stirred up. And then I'll turn on my flashlight. And if you have someone else at home who can help you hold this while you stir it, you might be able to see this even better. Let's see if I can manage to hold it in one hand and stir it with the other. And that is creating even more flickering of this light. Just like a star seems to twinkle a lot when you're looking up through the atmosphere. So now that we know why stars twinkle, let's talk about why refraction is important to know about. Because of refraction, we don't get as clear of images when we're using a telescope here on Earth. So this is the telescope that we have here at the library, and telescopes work by taking all of the light that's in front of them, and then that light comes into the telescope and it is concentrated down here at the bottom because there is a mirror on the inside of this telescope, and the mirror is angled in such a way that it collects all of that big light down into a little funnel, and then that is directed at your eye. So you're able to see a lot in a very concentrated space, which is what helps us see things that are really far away much more clearly. But because this telescope is looking at things that are through the atmosphere, all of the light that is collected into this telescope experiences refraction because it's hitting those water droplets in the atmosphere. And because of this, images are not quite as clear as they could be if there weren't any water in the air. Now, of course, we need water in the air in order to survive, so we're very glad that it's there. But we've been able to get much clearer images by taking our telescopes and putting them out beyond the atmosphere. And that's what's up here on this screen right now. So I have a picture of the Hubble telescope on this side, and then a picture of the brand new James Webb Space Telescope. And these are both telescopes that are outside of the atmosphere in space. And so they are able to take really fantastic images of stars with greater detail than any telescopes that are here on Earth. The Hubble has been in space for about 30 years now, but the James Webb Telescope was actually just launched in December, so we haven't gotten any photos back from the James Webb Space Telescope. But because its mirrors are much more powerful than those of the Hubble, we're really expecting to see really amazing things using this telescope, including galaxies and planets that we have never gotten clear images of before. And if you're interested in learning more about the James Webb Space Telescope or using our telescope here at the library, definitely keep an eye out for upcoming NASA at My Library programming because we have a lot of cool stuff coming up, including a star party where our patrons will be able to come use our telescopes. You can also check out some of our other STEAM Club videos. For example, in our video about balloon rockets, we talked about the rocket that launched the James Webb Space Telescope into space. Thank you all so much for watching STEAM Club today. I hope that you enjoyed learning the answer to the question, why do stars twinkle? I also hope that we will see you here at the library for even more NASA at My Library programming, both in person and in upcoming STEAM Club videos. Have a great day!